Next is dot product. A dot product of A and B can be defined by A dot B equal to AB cos theta. It used to determine the angle between two vectors. The angle theta is the smallest angle between two vectors and always in a range of 0 degree to 180 degree. The result of dot product is scalar. Here you can see the dot product A and B vector and resulted in here. Here you can see the application of dot product in real life case. For this part, please refer to your handouts. This is a parallel. This is a parallel. This one is a tangent. Please do read this part. So for this part, for you to remember, if you have F at angle of theta, we can resolve that into X as F cos theta and Y as F sin theta. This is what you're going to apply in this handout. So once again, this is a tangential, this is a parallel. So for this part, the detail calculation you can see in your handout in here. So it explains everything how we can get into this equation. Hopefully you're going to see this by yourself. Next, we're going to do example 2.15. The force are acting on the hook at point A. Determine the angle between the force and line AO and the magnitude of the projection of force along the line AO. So first of all, we need to identify position vector for RAO. For that, we need to identify coordinate for position O and A. So here is coordinate O and this one is coordinate A. So we need to identify position vector ROA. That means O minus A. So 0 minus 1. 0 minus 1 is negative 1 for I. Then 0 minus negative 2. 0 minus negative 2, 2, positive 2 for J. Then 0 minus 2. 0 minus 2, we get negative 2 for K. So we done position vector ROA. Then in the question given position vector for F in the question as negative 6I plus 9J plus 3K and the unit kilonewton. Then we need to identify magnitude. So magnitude for ROA is negative 1 power of 2 plus 2 power of 2 plus negative 2 power of 2. Square root, we get 3 meter for magnitude ROA. Then we need to identify magnitude for F. So negative 6 power of 2 plus 9 power of 2 plus 3 power of 2 square root, and we get magnitude for F is 11.22 kilonewton. Then we need to establish the dot product for F dot ROA. Remember I told you for the dot products, this is the form of dot product. So for AX BX is negative 6 times negative 1. So negative 6 times negative 1. For AY BY, 9 times 2. So 9 times 2. For AZ BZ, 3 times negative 2. So the answer for FRAO is 18 kilonewton meter. So from that we can calculate angles. So angle is the established dot product divide the magnitude. So 18 divided by magnitude FR times by RAO. And please do remember the unit for 18 is kilonewton meter. The unit for magnitude is 11 kilonewton times meter. So kilonewton meter. So we simply can cancel it out. We get our theta is 57.67. So we know our theta is 57.67 degree. Back to basics trigonometry, we take this triangle out. So this is a form of that 90 degree, and this is theta, and this one is FAO. So we can use trigonometry. We take cos theta, then we can find what is our FAO. So our FAO is F cos theta. FAO is 6 kilonewton. Or we can find magnitude of our projection force by using this formula. FAO equal to dot product F dot UAO. So we find our UAO is RAO divided by the magnitude. So RAO, so on I, RAO is 1. For its magnitude is 3. So 1 divided by 3 on I. Then for J, 2 divided by 3. 2 divided by 3. Then for K, negative 2 divided by 3. So we get our UAO. Then we can find our magnitude of the projection force FAO, F dot UAO. Value F on I, negative 6 time UAO, negative 1/3, negative 1/3. Then on J, 9 time by 2 divided by 3. And for K, 3 times negative 2 divided by 3. The value for the projection force for FOA is 6 kilonewton. So check both if the same answer. You can use this method, FOA equal to F cos theta, or FOA of dot product F dot UAO. So the answer will be the same.